Hello everyone, I am Dr. P. Iris Punitha, Assistant Professor of Computer Application working at Bishop Heber College. I am excited to welcome you all to today's lecture on robotics and its application. In this session, we will explore fascinating topics such as Introduction to Robotics and its brief history, the key components that make up a robot, different classifications of robots, understanding their workspaces, work envelope, the motion of robotic arms, various types of end effectors and its application, and the wide range of service robots and their real world applications. We'll also look into how artificial intelligence is transforming the field of robotics, making robots smarter and more efficient than ever before. I hope you find this session engaging, informative, and inspiring. So let's get started with the introduction to robotics. What is robotics? Robotics is a branch of engineering and computer science that involve the conception, design, manufacture and the operations of robot. As we all know, it combines multiple disciplines such as mechanical engineering, electrical engineering, computer science and artificial intelligence. Robots are used to perform tasks that are dangerous, repetitive or require high precision, enhancing human capabilities. Robots can take on number of forms. A robot might resemble a human or be in the form of robotic applications. Let's see the early history of robotics. Ancient concepts. In ancient times, as early as ancient Greeks, the myths described mechanical servants. The robots can be called as mechanical servants. And in 1921, Corporal Chepak introduced the word robot in his play Rosum Universal Robots. And in 1950s, Isaac Asimov formulated the 3 laws of robotics, emphasize safe robot human interaction. And in 1954, George Devol invented the first programmable robot, Unimate, later used in General Motor factories. In Stanford Research Institute, robot dubbed Shaky followed suit in 1966 as the first mobile robots, thanks to software and hardware that enable it to sense and grasp environment through it in a limited capacity. And in modern times, robots involved with developments in AI, sensor technology and computing powers, leading to robots in industries, healthcare, homes and even space exploration also. So let's see the robotics applications. In today's industrial robots as well as many other types of robots are used to perform repetitive tasks. They can take the form of robotic arm, a collaborative robot, a robotic exoskeleton or traditional humanoid robots. Let's see some of the application of robots. Home electronics, home monitoring. Home electronics means like it perform the task without human intervention. Home monitoring means it can be used to provide home security. Artificial intelligence is something different from robotics, but robotics is widely used in AI and machine learning to predictive maintenance and process automation. It can be used in data science, law enforcement and military, mechanical engineering, mechatronics, and even it can be also used in nanotechnology, bioengineering and healthcare, and also in the aerospace. Let's see the types of robots. Okay, with the example, robots are designed to perform specific tasks and operate in different environment. Let's see some of the common types. Industrial robots can be used in industries like it can perform welding, painting, assembling, material handling like that it can perform. And service robots, the examples include cleaning robots, entertainment robots and personal assistant robots. Medical robots, it can assist the Healthcare persons, a robotic surgery system, exoskeleton, artificial limbs are few examples of medical robots. Autonomous vehicles, mainly it includes self-driving cars, drones, and autonomous delivery robots. They can navigate and make decisions using advanced sensor and AI algorithms. Humanoid robots, it just take the human like structure and are employed in research, entertainment, and human robot interaction. Cobots, cobots or can share workplaces with the human employees, enabling them to work more productively. And agriculture robots, it can help the farmers in planting, harvesting, apply pesticides and check crop health also. Exploration and space robots, these types of space robots can be used in all the space missions. And defense and military robots, it can be used in specifically it is used to designed to operate in unknown territories, and all it can be assist all military task. Educational robots, it mainly involved in education of the kids. It can be used for programming and problem solving. Entertainment robots, these entertainment robots are created for entertainment purposes, purely for entertainment purpose. It can be act as a pet or humanoid companion or interactive toys. Then components of robotics. Components means components, key components such as sensors, actuators, control systems, and sometimes an end effectors. These components are used to perform tasks autonomously or semi-autonomously. These are the components. With the help of these components, the robots are made. We can say like that also. First component is manipulator, end effector, locomotion device, controller, sensors. These are the main components. First one is manipulators. It is similar to the human arm, and it provides flexibility and movement to the robot. And it can also, just like a human arm, it can bend and reach reach the different positions and orientations. End effectors. The end effectors, these are the tools or devices at the end of the robotic arms, like grippers, weldings, and torches. The end effector perform tasks like gripping, picking up objects, or performing precise actions. Locomotion device, it is like a motors provide the power needed for the robot's movement. They come in various types including electric, hydraulic, and pneumatic. Controller, this is the controllers act like a brain that process data and controls actions, includes microcontrollers and CPUs. Sensors is the most important part of robotics. Detect environmental conditions like proximity, temperature, and light. Let's see the classification of robotics. Types of robots. I have given some of the robots that are used in different areas, and each robot has its unique features. As a whole, robots vary hugely in size, shape, and capabilities. Let's see some of the robots. Aerospace robots. The purpose is operate in space exploration and atmospheric study. See here I have given bird-like robot and human-like robot. These aerospace robots are highly used in the space exploration. Aquatic robot. It is mainly designed for underwater and surface water task. Aquatic robots. See here I have given some of the pictures. Cylindron on the open seas. Snake goes underwater. These are mainly used in underwater or surface of the water. It can be mainly used in water surveillance missions. Whenever the human are afraid of getting wet or getting drowned, these types of aquatic robots are used in the dangerous works. Then autonomous vehicles. The purpose of the autonomous vehicles are self-driven cars, air or water vehicles. I have given few examples. So these are the robots. Robotic cars equipped with the cameras, lidars, GPS, computers, and other sensing and navigation systems that enable them to drive fully and autonomously. So next one is consumer robots. The purpose of the consumer robots are designed for everyday use by individuals. So I have given few example pictures. So these are the robots you can buy and just use for fun or help you with the task and home chores. Then delivery robots. The purpose of these robots are transports goods autonomously. I have given few examples. Snack robot, rely on your toiletries, zipline parachute delivery. These robots transport items like foods, groceries and medical supplies from one point to the other. Disaster response robot. So the purpose of this types of robot are aids in rescue and relief operation during disaster. Drones. The purpose of these type of drones are unmanned aerial vehicles for diverse application. Without the help of the human, we can use these types of robots for diverse applications. Educational robots. The purpose of these educational robots are teach robotics and programming to students. Next one is entertainment robots. Purpose amuse and engage users. The entertainment robots are designed to evoke an emotional response. They can make us laugh or feel surprise or wonder. So exoskeleton. The purpose of these types of robots are wearable robots to enhance human strength or mobility. These type of robots suits equipped with electric motors that help move the user's body. Some powered exoskeleton can even give the wearer superhuman strength. Exoskeleton can be used for physical rehabilitation and can enable a paralyzed person to walk again, like exo and hall robot suits. Some exoskeletons like the Guardian Exo have industrial application by giving the wearer added mobility, endurance or the capacity to carry heavy loads. While using the exoskeleton we can feel like a superhuman. Humanoid robots. The purpose of the humanoid robot is mimic human form and behavior. The robot's body typically has a mission-like appearance, as in the case with the humanoids like friendly robot ambassador Asimo from the Honda and the athletic agile Atlas from Boston Dynamics. But humanoid can also have a human-like appearance. Example includes Geminoid family of robots which resemble real people face, and it can be used in assist all the human needs. Industrial robots. The next one is industrial robots. It is used to perform tasks in manufacturing. Like industrial robot perform repetitive tasks like picking, moving and assembling parts, plus cutting, welding, painting, polishing, packaging and other jobs typically found in manufacturing. Medical robots. These types of robots are used in assist the healthcare and surgeries. Military and security robots. It can be used to defend for defense operation and surveillances. The military and security robots includes broad range of tough, rugged robotic systems that can perform surveillance and other missions that may be dangerous for human to carry out. Then the next one is research robot. These types of robots are experimental missions born in universities and a corporate research lab. Though these robots may be able to do useful things and some may fit other robot categories, they are primarily intended to help the researchers to do well research. Next one is service robots. These service robots perform useful tasks like cleaning, greeting visitors, or making deliveries. The next one is social robot. Social robot are designed to interact and communicate with the human, assist us with the daily tasks like grocery list and calendar events, or simply keep us company and make us smile. Telepresence robot. So this type of robots allow you to present at the place without actually going there. You log on to a robot avatar via the internet and drive it around, seeing what it sees, hearing what it hears, and talking with the people you encounter in meetings or at a water cooler. So next one is workspace robotics. Workspace of a robot actually refers to the entire volume or area the robot's end effector can reach. It depends on the robotic's arm length, number of joints, and range of motions. A large workspace allows a robot to perform more tasks without being repositioned. It's a crucial factor in robotic system design, especially in manufacturing. Work envelope. Work envelope is the three-dimensional space in which a robot operates. It defines the limits within which the robot can move. Different robots have different shaped envelopes, like like Cartesian robot. Cartesian robot means rectangular box shaped. Scara robots, it is cylindrical in shape. Articulated robot, these are spherical or irregular in shape. Knowing the work envelope helps in selecting the right robot for specific task. So, major types of motions are linear, rotational, Cartesian, cylindrical, spherical, articulated, Scara, and delta. See here, linear motion. This is one of the basic robotic move. That is, it is in a train-like structure. It will go and come back in a linear motion. Rotational motion. Rotational motion is like cylindrical, a spinning top or dancer twirling. That's rotational motion. It works like this. It can rotate in 360 degree and turn off the entire arm to perform the task. See here, I have given some of the images for you. Next, Cartesian motion. This type of robots that follow each of the Cartesian coordinates in a straight line. It has a work envelope that resembles a box and can be swept away using the setup. See here, it's like a box-like structure. Cylindrical motion. It permits. See here, I have given the image here. It permits the tool it uses to revolve along a central axis. The tool may also travel up and down the center axis as well as in both directions toward and away from it. With this arrangement, a cylindrical shaped work volume is produced. Next one is spherical motion. See here, this is the diagram. This arrangement produces a tool action that sweeps out a workspace with a spear-like form. It allows the tool to revolve around the primary axis and the second axis that is positioned at a 90-degree angle to the main axis. And the tool can also pivot around an axis. Articulated motion. This is the image of an industrial robot that comes to mind when the term is used most frequently is this one. It must have a wrist joint, an elbow joint, and at least one shoulder joint. Both main and minor axis can be included in many of these setup instances. Next one is Scara motion. It uses pivot points to enable its tools to move in both cylindrical and Cartesian movements. This enables the tool to move more swiftly and with more ease while making particular motion like an arc. The last one is delta robot motion. It is the robot configuration type that can move its tool the quickest. To enable its tool to swiftly sweep out its workspace, it employs parallel connection. See here I have given the articulator robot, linear robot, grand teeth robot, cylindrical type of robot, SCARA robot, parallel robot. So I have given the examples for you to for your references, and also I have given the summary of the above told information. Articulator, delta, and all the types of robotic arms. So the next one is end effectors. End effectors are the devices that attached to the robotic arm's end used to interact with the environment. So these are the types. So these are the types of end effectors: grippers, the three main categories: grippers, processors, tools, and sensors. So types: grippers, mechanical grippers, clamp like gripper, suction vacuum grippers, it is used for suction. Magnetic grippers, it is used for magnets for ferrous object. Tools: welding torches, spray guns, screwdrivers. So all these types of end effectors are used to hold something, some item to work. The robots can hold some item to work with the help of these grippers. Specialized end effectors include that can be used for medical or agriculture or underwater application. So these are the sensors. Robotic sensors are like robotics eyes and ears, helping it move it in the right direction, understand what happening around it. So there are some of the common sensors: ultrasonic sensor, proximity sensor, torque or force sensor, light sensors. So ultrasonic sensor can be used to find measure the distance using sound waves. A proximity sensor, this is space sensor. And torque force sensor means push and pull force happening at the robotic wrist and joint. Light sensor, these let the robot measure how bright the things are. So these type of sensors can be used by the robots to send signals to a controller which tells the robots what to do next. So I have given all the types of sensors used in the robots. So see here I have given proximity, temperature sensor, ultrasonic sensor, vibration sensor, tilt sensor, level sensor, touch sensor, soil moisturizer sensor, gyroscopic sensor. Gyroscopic means it can be used in acceleration. It can be used like an accelerator. Service robots and its applications. So we have came to service robots and in applications. So service robots perform useful tasks for humans or equipments excluding industrial automation. So there are some of the applications: healthcare. These types of service robots can be used in healthcare, domestic, hospitality, security and surveillances, entertainment. So we have seen many of the service robots and its application. So I have given the robots in the classification of service robots. I have classified the service robots and its classification. So service robot, the first one is personal service robot, professional service robot. So personal service robot or personal service robots or A service robot for personal use is a service robot used for non-commercial task by lay persons. Example or domestic servant robot, automated wheelchair and personal mobility assist robot. The next one is professional service robot. These are the service robots used for professional use only. Professional use only. Example, the service robots used for commercial task, only commercial task, usually operated by a properly trained operator. Examples, cleaning robots for public spaces, delivery robots in office and hospitals, firefighting robots, rehabilitation robot and surgery robot in hospitals. In this context, an operator is a person designated to start, monitor and stop the intended operations. So robot system is a system comprising robots, end effectors and any machinery, equipments, devices or sensors supporting the robot performing task. So I have given the service robot for personal and domestic uses. So robots for domestic task. See here I have given some of the examples. Robot companions, humanoids, vacuuming, floor cleaning, lawn mowing, pool cleaning, window cleaning, others. See, so these are the domestic task handling robots. Next one is entertainment robots. Toy hobby robots, multimedia remote presence, education and research and others. Elderly and handicap assistants. So these are also used for personal or domestic uses. Robots, robotized wheelchairs, personal aids and assistive devices, other assistant functions. Personal transformation, home security and surveillances, and other personal domestic use robots. So these types of the given types of robots are for professional use. For example, I have given field robots, professional cleaning, inspection and maintenance system. So in the above slide we have seen the non-professional use, that is personal use robots. These service robots are for professional use, completely commercial use. First one is field robotics, agriculture, milking robots, other robots for livestock farming, forestry and silviculture, mining robots, space robots and other field robotics. Personal cleaning, floor cleaning, window and wall cleaning, these are for only commercial purpose. This is not in domestic purpose, this is completely commercial. Tank, tube and pipe cleaning, hull cleaning, articraft vehicles etc. and other cleaning tasks. Inspection and maintenance system, these also are for commercial use only, not non-commercial use. Inspection and maintenance system, facilities, plants, tank tubes, pipes and sewers, other inspection and maintenance system. Construction and demolition. So nuclear demolition, this can be used in even nuclear demolition and dismantling, building construction, robots for heavy civil construction, other construction and demolition systems. So logic systems. So automated guided vehicles, manufacturing environments, AGV, non-manufacturing environments, indoor, cargo handling, outdoor logistics, other logistics systems. Medical robots. Medical robots, we have seen enough for the medical robots. Diagnostic systems, surgery assistant systems, rehabilitation system, other medical robots can be called as medical robots. Rescue and other security applications, defense application, demanding robots, unmanned aerial vehicles, unmanned ground based vehicles, unmanned underwater. So we have seen enough examples for these defense applications, medical robots, rescue security application robot and all the thing. So next one is application of service robots, retail services, agriculture services. We have seen this. So we have classified the service robots as domestic service robots and professional service robots. So these also can be divided: retail services, agriculture services, domestic services, event services, industrial cleaning, and logistic makeup services. So the last topic we have came to the last topic, that is artificial intelligence in robotics. So robotics is something different from artificial intelligence. It is a separate entity of artificial intelligence. This helps the robots to be intelligent. Robotics combine electronical engineering, mechanical engineering, electrical component, and programmed with the programming language, and it gives a special feature of artificial intelligence. Unlike early robots, today AI powered robots can retrieve data, learn from the experience to predict the future decisions. Although robotics and artificial intelligence have both different objectives and application, but most people treat robotics as a subset of artificial intelligence. But robotics have different path and artificial intelligence have different path. Once we combine the robotics with artificial intelligence, machine learning, deep learning, and sensors, actuators, and this will gives a best output for the humankind. So I have given the difference between robotics and artificial intelligence. See here, definition I have given the summary like structure, definition, scope, physical presence, components, interrelations, and examples. So let's see the applications of AI in robotics. So there are AI here are some key applications of AI in robotics with real life examples of how this technology is being utilized. AI in robotics is transforming industries by enabling robots to autonomously perform tasks that were once reliant on human intervention. Autonomous navigation. First one is autonomous navigation. This is especially used in industries like logistics and manufacturing. Machine learning for predictive maintenance. This reduces downtime and ensure that industrial process runs smoothly. The next one, surgical robots, AI powered inspection and quality control, AI for search and rescue operation, human robot collaboration, that is cobot, personalization and customer services. So we have using AI powered robots in our day to day life. They are they are voice assistants like Siri, Alexa, Google Assistants, like that. Streaming services like Netflix, Spotify, recommended movies, shows, and music based on user viewing habits. Social media algorithms, email providers, fraud detection and finance. We are unknowingly, we are in our day to day life, we are using the robotics without knowing that we are using the robots. We are day to day life, we are using robots. AI empowers robots to handle unpredictable environments, making them smarter, more flexible, and more efficient. AI plays a critical role in enhancing robot intelligence and autonomy. Autonomy means robots make decisions without human input. The machine learning. Robots improve performance based on data and experience. The computer vision. It can recognize objects, people, and scenes. And natural language processing. Communicate with the human through speech and text. Path planning. Navigation through complex environment. So, in today's section, we have explored some important basic concepts of robotics that has included introduction. We have seen introduction of robotics, brief history, workspace, classification, components, work environment, motion of robotic arm and end effectors and types, service robots and its application. So these are the things we have seen today. Hope you have enjoyed the session and you have learned some of the useful content of robotics and and its application. We have seen so many service robots, consumer robots, industrial robots, agriculture robots. So we have seen some professional and non-professional robots, AI powered robots also. So I hope this session is very much useful for your the next sessions. It can be very much useful for your day-to-day life, and this can be used for your syllabus and subject also. Okay, let's see in the next session. Until then we'll depart with this. Okay, thank you everyone. We'll see in the next session. Thank you.